Welcome students. In this lecture we are going to discuss translational and rotational motion and what is moment of force, or we call it torque. So let's get into the topic. Translational and rotational motion. The first one we will discuss is translational motion. Translational motion, or another name for it is called linear motion or linear motion. Okay, so what is translational or linear motion? If an object moving in a straight line, if an object from here to, let's say it is moving from here to somewhere over here, this motion of an object in a straight line is called translational or linear motion. For instance, a car is moving in a straight road. What is it? It is linear motion. So by definition what we can write is an object moving in straight line. This is called translational or linear motion. Right. The example for it, as I discussed, what is it? The car moving in a straight line or in a straight road. In a straight road. This is example of translational or linear motion. Next one is rotational motion. Rotational motion. So what is rotational motion? It is quite, you can understand from the word itself. Rotational motion is an object is rotating about an axis. About its axis is called rotational motion. I think the concept is clear. When an object moving about an axis or a pivot is called rotational motion. So I will write it. An object moving about an axis or a pivot is called rotational motion. Hope you understood. Hope you understood. So what actually, for instance, a wheel, right? A wheel is rotating about its axis. So let's say it is moving in this clockwise direction. Of course, it consists of not only rotational motion. For instance, the wheel of a car, it is rotating, and of course it is what? It is moving also. In a straight line also it is moving. So it is actually the combination of what? Rotational and linear motion. When an object is, for instance, a car is moving, the wheel is rotating, on the same time it is moving under linear motion. So here we are only discussing about the rotational motion. I hope you understood. No doubts in this. Okay. Next one is moment of force. Moment of force, or another name for it is called torque. What is torque, or what is moment of force? It is the turning effect of a linear force. For instance, if we tell an example, opening a door. Okay, when you open a door, you are applying a force perpendicular to you. But what actually happens, it is bringing a rotational tendency. It is rotating, right? The door is rotating because it have a pivot, hinges, right? Hinges at one end of the door. So that is the reason why what happens, it rotates. I will write it first. The rotational tendency of a body when an applied force acts on it is called moment of force. I will write it. the rotational tendency of an object or of a body when an applied force acts on it is called moment of force. Right. So moment of force is when an applied force is acted on an object, the turning effect is generated in the body is called moment of force. Right. So for example, as I said before, a door and the hinges are applied, or hinges are there in the one of the ends. Right? So when you apply a force in this direction perpendicular to you, you push or pull, what happens? It starts rotating, isn't it? It will rotate in clockwise or anti-clockwise direction, depends on the force which you applied, the direction of force you applied. So this is basically moment of force or torque, or we usually call the turning effect. The turning effect. Now, what is the mathematical expression for it? Mathematical expression for moment of force. Remember, moment, or I will write it, mathematical expression for torque. Right. Mathematical expression of torque, we can write it. Remember, torque is equal to, or torque or moment of force is equal to force times the force which you apply times the perpendicular distance. This is the perpendicular distance from the force and the hinge. Got it? This is the perpendicular distance. I will write it is d perp. So force applied times the perpendicular distance from the force applied to the hinges or pivot. I hope you have no doubt in this. So moment of force or torque is force applied times the perpendicular distance from the force applied to the pivot. Or if you write in mathematical notations, moment of force, we can write moment of force as itself. Moment of force is equal to force times the applied force, that we can write F times perpendicular distance d perp. This is very important equation to remember. These concepts will be more clear when we start doing the numericals on these concepts. Then only it will be deeply rooted in your mind. So hope you understood this much. The next, in between, what is the SI unit of it? SI unit of torque or moment of force. Right. So it's obvious what is the unit of force, that is Newton, and d perp is meter. So it is Newton meter. Of course, there will be an ambiguity. We know that Newton meter force into displacement. We learned it somewhere. What is that? It is work done also. So is it joule? No. So it is just Newton meter. We will discuss in detail later why it is Newton meter. So what is the CGS unit? CGS unit of moment of force. If you see in the previous lecture, we understood that 1 Newton is equal to how much? Dyne. CGS unit of force is dyne, right? So 1 Newton is equal to 10 to the power 5 dyne it is. Then what is the CGS unit of what? Moment of force. CGS unit of moment of force should be, okay, this is 1 Newton, so 1 Newton meter it should be, right? 1 Newton meter should be equal to 1 Newton is 10 to the power 5 dyne. 1 meter, how much centimeter? 10 to the power 2 centimeter. So it should be 10 to the power 5 dyne times 10 to the power 2 centimeter. So remember, it is 10 to the power 5 times 10 to the power 2 dyne centimeter. That is 10 to the power 7 dyne centimeter. Dyne centimeter. Right. So this is dyne centimeter is the unit of moment of force in CGS unit. That's it for the second lecture. In next topic, we will do the topic called couple. Couple, and the next section of it is called clockwise and anti-clockwise moments. So these are the things. We will do some numericals also based on this topic. Hope you all enjoyed the session. Thank you so much. See you in the next lecture.